So let's look again into the power rule. The power rule for n is any constant or real number, and we want to take the derivative of x. That will gonna be x to the power n. Then the derivative will be n x to the n minus 1. Now let's look to these examples. We want to differentiate, so we want to find the derivative of each of these functions. The first function is 1 over x3. Let's rewrite this function. This function can be written as x to the negative 3. And then we are now ready to take the first derivative. We just apply the power rule, and that will be our derivative. Now for b, it's already ready, so we don't have to write anything. So the half will come down, and then the half will be subtracted by 1, and then it's gonna be negative half, and that's the derivative. And also this can be written as half multiplied by 1 over x squared. For c, we have 1 over the root of x third, x to the 3. This can be written as 1 over x to the third, and then also this can be written as x to the negative 1/3. Now we are ready to apply the power rule. So negative 1 over 3 will come down, and then it will gonna be subtracted by 1. That should be our answer. So in this example, we are giving this function x to the negative 2, and we are asked to justify the power rule. So we want to use the definition of the derivative, which is the different quotient, to have the same answer, that is negative 2x to the minus 3. So we start by writing the definition of a derivative. And then first we take the first term, which is of x plus h. That term gonna be, when you plug it to our function, it's gonna be 1 over x plus h squared. And then we can expand this term here by using this shortcut here. That's gonna be 1 over x squared plus 2xh plus h squared. Now what we can do is bring the whole term together again. We will substitute off of x plus h by what we find in the last step. And then this is our function of x, and then all over h. Now we have two fractions. We need to solve these. So I'm gonna solve these first. Let's rewrite these. Here I'm just writing the top of the fraction so that I can solve it. So I will take the first fraction to find the common denominator. I will multiply both of them by x squared. So first one will be x squared, and the bottom will be x to the fourth plus 2x third h plus h square x square. And then second step, we will take the second term, which is 1 over x squared, and we want to find the common denominator. We can multiply that by x squared plus 2xh plus h squared, top and bottom. So at the top gonna be the same since it's multiplied by 1, and then the bottom will be x to the fourth plus 2x cubed h plus h square x square. Now we'll take, third step, we'll take the whole term and then subtract. So here I'm just rewriting that fraction, and now I'm writing the results from these steps back. So again, I'm just rewriting these into our terms so we can simplify later. Now they have common denominator. Now we can subtract the bottom. Subtract the top. The bottom gonna be the same. Here we notice there's a negative sign. What I'm gonna do when I write this, I'm gonna multiply this negative sign by the whole term. So all their sign gonna change. We can see that x squared minus x squared is 0, so both of these terms will go. And this is what we left with. This is, remember again, this is only the top of the limit. So now we found the top of the limit. Now we'll go back to the limit and blank it there. So what I'm doing is just moving that answer to the top of our fraction. And remember, this is all this fraction is over h. Now what we can do is simplify. So the square will go and then h will go. So now we can write this as limit as h goes to 0, negative 2x over x to the fourth plus 2x cubed h plus x squared x squared. Now we can use the definition as h goes 0, so all the term with h will be 0, and what's left off is negative 2x over x to the fourth. Notice that the second term at the bottom will go away. I made a mistake here, so here what gonna be, I'm gonna rewrite this again. So as h equals 0, all terms gonna go to 0. So what left over is negative 2x over x to the fourth. That's the whole term. Now we can simplify the x's, and then we can rewrite this function, and we can see the result, exactly the result, by using the power rule.